Assalamualaikum and hello everyone. Welcome to the video on how to write down the experiment 2 lab report SK015, which is the acid-base titration determination of the concentration of the hydrochloric acid solution. Okay, before we look further into the lab report, let us recap back on what must be included in the lab report or the format for your chemistry lab report. For chemistry, what is needed in your lab report writing is actually the objective, theory, procedure, results or observation, discussion, and last but not least is conclusion. Again, your apparatus and region is not needed in the lab report. Okay, it's not compulsory. Okay, so let's look into detail for experiment 2. Before anything, what you need to have in your lab report, first is your name, metric number, and class. Okay, and then don't forget to include the title of the experiment itself. Okay, so now let's look back for the lab report. It is mostly based upon our lab manual itself. So how to write down the objective? When you write down the objective in your lab report, you can refer back to the objective in your lab manual straight away. Which in this experiment, we have 4 objectives. 1, 2, 3, 4. We have these 4 objectives for this experiment. So to write down, we just write down 2, prepare a standard solution of oxalic acid, 2, standardize 0.2 molar now solution, 2, determine the concentration of HCl solution, and 2, acquire the correct technique of titration. So for this experiment, this is the objective. The objective for the experiment itself. Okay, so you have finished, write down the objective for your lab report. Okay, so for the theory is actually where it is based on your introduction in your lab manual. Okay, if you look back based on the format of the lab report here. Okay, for the theory here, it mentioned that for the theory, write concisely in your own words, draw and label diagram if necessary. For experiment 1, I have asked you to write down all the 2 paragraphs of the introduction in your lab manual. But for experiment 2, it's quite a long one. For experiment 2, you have a bit like 1, 2, 3, 4, 5, 6 paragraphs of the theory. So what I would like you to do is to summarize it. Okay, so when you summarize it, it's actually I have written down lah what is actually the thing that must be included in the theory itself. So for example here, I have written down in a numbered list the theory 1, 2, 3, 4, 5, 6. So from this one, okay, you only have to answer it lah. This answer could be found in your introduction. Okay, so for example, let's look for the theory number 1. So number 1, titration is used to, okay, so you have to find out in the introduction lah, mana titration is used to. So here it mentioned that titration is a laboratory technique used to determine the concentration of a solution using another solution with a known concentration. So maknanya kat sini, the answer is from here until here. Okay, so the same for question, the next question. Except for question 2. Question 2 is not, for the answer for question 2 ni, is not included in the introduction. So yang ni kena find out sendirilah, find out yourself. Okay, but then most of this question, okay, so for example, I'm just going to show you yang number 6. Endpoint is, so if it's not here, then you have to find out for the next page lah, from your lab manual. So here, where's the... Here we have equivalence point and endpoint. Okay, so question number 6, you mentioned that endpoint is, so kita tengok balik. Endpoint is, kat sini, the point at which the indicator changes color. Okay, so for the theory, you don't have to write down all of your introduction. Make sure you answer based on this question that I have asked you to lah. This is actually, I have summarized it for you. So make sure you answer all of these questions. Okay. So next, again, for the apparatus and chemical reagent, it's not compulsory for you to include in the lab report. Okay, and then for the procedure, for this experiment, we have part A, part B, and then part C. Okay, remember for the procedure, it must be in here. The procedure must be in passive form and it must be in past tense. So again, it must be in passive form and then make sure they're past tense. Because you have done it in the past, you have done the experiment, then you write down the lab report. Okay, so for this one, I have written down lah from here. So if you want to pause it here, okay, so part A, I have done it for you. So it's quite straightforward. I believe you're confident because you have done for the part, for the experiment 1, the same thing where you have changed it into passive sentences and then change it into past tense. For part B and part C, I believe you could try it yourself. Okay. Okay, for the next one, what you need to do, what you need to include in your lab report is the result. Okay, for the result, okay, so for first, part A, preparation of standard solution. Okay, so for the standard solution, first, what you need to do is actually you have to weigh in the mass of hydrated oxalic acid using analytical balance. So here is your mass. Next, we have to find out the number of moles here. So the number of moles, so we assume this is our solute, it will be mass over molar mass. Okay, so for the molar mass, remember for this one, how many will be easier for you to calculate it based on, you have to count how many carbon, how many hydrogen, how many oxygen is present. So here must include the 2H2O as well. Okay, then you will find out the mole of our oxalic acid. So for the molarity or the concentration, it is the number of mole of solute divided by volume of solution. Okay, the number of mole of solute is the one that you have found out from the previous step. Okay, the volume of solution is 0.25 liter because you have prepared it in a volumetric flask which is 250 ml. Okay, but then again, for the molarity, the volume must be in liter. So that's why here is 0.25. Hence, you will find out the first result or first concentration, which is the concentration of oxalic acid. Okay, so that is for part A. Okay, so for part B is the standardization of 0.2 molar noun solution. Okay, so from here, okay, the given noun solution is 0.2 molar. So right now we want to calculate, do we get the value is to be 0.2 tak? Okay, so for the result, again, for your burette, it must be in 2 decimal places. So even though kita punya burette tu is actually here, when we count, when we find out the burette, here we can see it's 0. But it's actually for burette is 2 decimal places. In the procedure itself, for the part B, it mentioned here that we have to record the initial burette reading to 2 decimal places. So it's not only for the initial only, your final and your volume must be in 2 decimal places as well. So this is the example of the value. So I believe you have find out the value yourself when you're doing titration. Okay, but then again, I just want to share here. Okay, so for this value, okay, what I would like for the result is to be, the value must be consistent. So the difference must be, for each of the reading, the difference must be maximum is 0.2 mil lah. For example, here, these two, the difference is 0.1. This one and this one, 0.1 as well. But the maximum difference in between these 4 reading is actually 0.20 mil. So for your lab test, then maximum is 0.20 mil difference lah. Then you get the point for your consistency. Okay, so however, when you calculate the average volume, you will only calculate the 1, 2, 3. Grossing, it means estimation. So we will not take this estimation to be your to calculate the average volume. Okay, so grossing is just for estimation. Once you have known how many mil of noun will be used, then you can do it 3 more times. Okay, then this 3 value will be included. So that's why I've mentioned here 1, 2, 3. Maknanya value yang sini. This one, no need for the gross value. Okay, so from here, you can find out the volume of noun. But then again, this step of the procedure here is to calculate the 0.2 molar noun solution or the noun solution itself lah. Okay, so first what we're going to do is actually we're going to do an equation between our oxalic acid and our sodium hydroxide. So this is the equation. this equation is actually included in your theory or in your introduction part of your lab report. So this one, the equation number 1. Okay, so this is the equation between our oxalic acid and our now solution. Okay, so from here we can calculate the the molarity of our base. Okay, we're gonna use the MAVA over MBVB equal to NA over NB. A stands for acid, B stands for base. Okay, so acid is our oxalic acid here. Base is actually our NaO. Okay, so M is molarity, V equal to volume. Okay, N is actually your number of mole. Okay, so how do we get number of mole ni? Number of mole tu depends on the equation itself. First, make sure the equation is balanced. So when you look here, our acid here is 1, our base here is 2. So that's why here 1 over 2. For the concentration, okay, again A stands for acid. A is the concentration which you have found out in step A, procedure A yang sini. This one. Okay. This one, you can include it in the MA here. Volume is 25 ml. Okay, so for the volume, if you use volume A in ml, so the volume B must be ml lah. If you want to take the volume of acid in liter, this one you have to write down in liter lah. Okay. Okay, why the volume of acid is 25? Because when you put in your conical flask, you pipette 25 ml of your acid. Okay, so that's why the volume of acid must be 25. However, for the volume of base, you have to find out from the average value. This one where you have calculated from these 3 value. Okay, then you will get the concentration of base, where you should get 0.2 molar NaO. Okay, so that's only for the part B. Okay, part C is the determination of the molar concentration of HCl solution. Okay, so the same one, determination of the molar concentration ni is actually our molarity lah. Where previously we have find out our NaO, right now we're going to find out our HCl. Okay, again for the average volume of NaO used, what we're going to take is actually the value of 1, 2, and 3. Okay, so you will get the average. After that, once you have found out the average volume of NaO used for this titration, what you need to do is actually you find out the molar concentration of HCl is Ma. A stands for acid. Okay, so this is the reaction equation for the reaction between HCl and NaO. So the same one, MAVA over MBVB over Na over Nb. M stands for molarity, V stands for volume. Okay, again, based on this one, I use the volume to be in ml, milliliter. So Ma is our unknown, the molar concentration of HCl. Volume of acid, the one that we have pipette into our conical flask, is 25 ml. Okay, the concentration of base, Mb ni, again, is actually our NaO. This is the one that we have found out from the previous step for part B. Okay, and then the volume here must be your average of NaO. Here, why is the ratio is 1 to 1? Because number of mole of acid divided by number of mole of base, here is 1 to 1 ratio. Then you will get the molarity of your acid. Okay, so that is the concentration of HCl solution. So this experiment, because we have 3 procedure, then we have to find out, actually for 3 different procedure ni, we're going to find out 3 different things. So that's why for the result, it's quite a long one lah, when compared to the experiment 1 punya result or calculation. Once we have written down the result, then we're going to discuss, for the discussion, we're going to discuss the possible errors and precaution. Okay, again, all the possible error and the precaution is actually, I've taken it based on the procedure itself. Okay, so let us discuss. So, for the possible error, for the first possible error that may occur during this experiment, it's actually excess volume of distilled water was added to the volumetric flask during the preparation of oxalic acid solution. Okay, so for the oxalic acid solution, okay, we have prepared in our volumetric flask, right? So here is actually our calibrated mark. So maybe the first possible error is that there is excess volume of distilled water. Okay, so once there is the excess of distilled water, then the concentration of the molarity of the oxalic acid would be further away from the theoretical value. Okay, so that's the first possible error that may occur. Okay, so what is the precaution? So again, the precaution is that we have to add the distilled water using a dropper when the oxalic acid solution nearly reach the graduated mass of volumetric flux. Okay, the second error that may occur is the parallax error at the burette or the measuring cylinder. Okay, so what is the procedure for the possible error? Takkan diterima kalau you only answer it as parallax error. You have to mention to be specific. Kat mana parallax error may occur? When you're taking at the burette ke, pipette ke, kat measuring cylinder. Okay, so here for the precaution or how to overcome it, you have to take the bottom of the meniscus that align with the graduated mark at eye level. So what does it mean? Selalunya kita akan ambil bacaan dia. Make sure eye level. For the measuring cylinder, usually we put it on a flat surface lah. Okay, so make sure. So contohnya sini is our 0 ke 10 ke. Make sure the bottom of the meniscus level tu, bottom of the meniscus ni is this one. It means that the curve one tu, okay, must align lah. Okay, make sure at eye level. Yang ni yang paling penting. Okay, next is air bubble trapped in the burette tip. So when you're doing the titration, so apa yang jadi sebenarnya kat bawah ni, it could be ada air bubble, ada macam air bubble drop here lah. So what we're going to do is actually to overcome this error is we remove the air bubble in the burette tip. Sometimes you just can jentik dia ataupun you just let it run lah the solution tu, and then you can once you let it run, you can add in the solution again into the burette, or you can just take the burette reading to as it is. Okay, next one, yang ni usually the popular error during the experiment adalah misjudging the colour of indicator near the endpoint. Usually, supposedly we will get pale pink. But sometimes when you doing too fast, kalau kamu laju sangat buat, sometimes kamu akan dapat colour macam purple sikit lah. Okay, so how do we overcome this? Okay, so here. Upon reaching the endpoint, titrate slowly until a pink colour persists for more than 30 seconds. Okay, so this is actually based on the procedure itself. So, jom kita tengok. So, here, steps number 8. Upon reaching the endpoint, the temporary pink solution appears but fades when the solution is swirled. Okay, so selalunya kat sini yang masalahnya kan. And then, kata continue titrating until a pale pink colour persists for more than 30 seconds. So, maknanya memang kamu kena buat slow just to make sure you get the pale pink. Okay, selalunya kat sini yang senang kita nak overshoot. Okay, so this is actually kat sini lah how to overcome this error. Titrate slowly until a pale pink colour persists for more than 30 seconds. And last but not least is the inaccurate volume of titrant during titration. So maybe sometimes you over added the base into our acid solution. So sebab tu lah sometimes colour dia lebih sangat. Okay, so how to overcome this? That's why we repeat the titration 3 times, and then for the calculation, we will take out the average. Okay, so that is for the discussion. And last but not least is the conclusion. Okay, so for conclusion, usually we will answer out our objective. So in this experiment, we have 4 objectives. So for the 4 objectives, usually for the conclusion, we will write down only the things that we have found out lah. Okay, so for the objective here, let us look based on the lab manual to prepare a standard solution of oxalic acid solution. There's no need to write down the conclusion. Here, standardize a 0.2 molar now solution. So here is our part B. And then for the result, kita dah calculate kan tadi part B kita, which is this one. Ni part B. Standardization of 0.2 molar now, where we have calculated the molarity as well. This one. So that's why this one we have to include into our conclusion. So bila kita tengok balik pada conclusion kita, here we have to write down the concentration of now solution is, it depends lah what is the value that you got based on your calculation. Supposedly it's 0.2 lah. Theoretically it should be 0.2. Okay, apa lagi we want to answer in conclusion? So number 3, determine the concentration of HCl solution. So we have to answer lah. The concentration of HCl solution is what? This is based on the calculation from part C. So part C yang mana? Di sini ni lah. The last calculation for your result. Okay. And last but not least, bila kita tengok objektif kita, is to acquire the correct technique of titration. Again, there's no need to include in the conclusion lah. Conclusion ni selalunya kita akan include apa yang kita dah kira. Okay. So that's it for this video. This lab report is quite a long one because dia step banyak juga. So I think if you have any question, do not hesitate to ask lah. Okay, so that's it for the video for how to write down the lab report for experiment 2 acid-base titration.